Okay, so we are going to talk about real and apparent depth. Why do we need to talk about this? Now, imagine you are at a swimming pool. Okay, now because of the clarity of that swimming pool due to the presence of chlorine, you see that the bottom of that pool will be very, very visible to somebody that is looking at it from the surface. Okay, so if you are looking at the surface of a pool, if you are looking at a pool from the surface, you will observe that the bottom is very close to the surface. Okay, if you don't understand the concept of refraction, you will think that that pool is not deep. But when you will know that that pool is very deep is when you try to lower yourself inside. So if you lower yourself inside without knowing how to swim, you will just drown because you think that it is not deep. Okay, so this thing is due to what? Real and apparent depth. So we are going to make an analysis and derive a formula so that you can use it to answer questions whenever they ask you. So looking at this, so imagine that this is my pool. This is my pool. Okay, this is the pool. And then an observer, we have an observer. This is an observer. Now, the distance between the surface of the pool and the bottom of the pool is the real depth. Is the real depth. Okay, is the real depth. Now, but when an observer is looking at the pool from the surface, because of refraction, the bottom will be elevated. It will be as if the bottom shifted up. Okay, so let's see what is going to happen. So the bottom moves up and then it will now be at this level. So the distance between this surface and where it is assumed that the bottom is called apparent depth. So R is real depth, A is apparent depth. A is apparent depth. Okay, now you should know that N is equal to R over A. That is the first formula we are going to establish here. The refractive index is N over A. R over A. N is equal to R over A. R is what? Real depth. A is what? Apparent depth. That is the first formula we are going to establish in this aspect. Now, I want you to look at this diagram again. You see that from here to here is also a distance, D. Now, that distance, D, is known as the lateral displacement. So, we say lateral displacement. Lateral displacement. If you don't call it lateral displacement, you can also call it apparent displacement. Apparent displacement. So always take note. Don't let it confuse you with A. Don't confuse it with A. A is always apparent depth. So whenever JAMB or any other exam body says apparent depth, know you are looking for A. Whenever they say apparent displacement, whenever you hear displacement, it means you are looking for D. Now looking at this formula now, you see that we can say R is equal to A plus D. What does that mean? Remember, from here to this bottom is R. From here to here is A. So this small side, which is D, if we add it to this A, we'll get the total height. So R is equal to A minus D. Or you say that D is equal to R minus what? A. So we are going to be using this formula to solve examples.